Here we see a boy trying to push a car, but the car does not move. This is because the car is at static equilibrium and will remain at static equilibrium unless acted upon by an unbalanced force, which the boy in the photo is unable to create. Now let's take a look at the forces that are acting upon the car. First, we'll take a look at the basics, which is the force of weight or gravity, and then the normal force, which is the force that is equal and opposite to gravity. Next, we have the applied force, which is the force of the boy pushing on the car. The final force acting upon this object is the force that prevents the boy from pushing the car, which in this case is static friction. So the car does not move because all the forces acting upon the car are balanced. Here we see some kids playing basketball, and one boy is running alongside another. He is moving at a constant velocity, and the forces of gravity and normal force are acting upon him. There is also the applied force of his feet pushing against the pavement as he runs down the court. And there is also the force of kinetic friction that is acting upon him through his feet sliding against the pavement, as well as the air around him. Now the boy is at what is called dynamic equilibrium because his forces are balanced and he is moving at a constant velocity, and will do so until acted upon by an unbalanced force. Here we see a girl playing basketball. Her first shot, she uses a small force, and in her second shot, she uses a large force. And the only difference between the two forces is the magnitudes of each force. So in her first shot, she uses a force towards the basket with a small magnitude. And as you saw in the video, she missed the basket. However, in her second shot, she shot at the same angle with a much larger magnitude. And as you saw in the video, this was the shot that actually made it into the basket. This is a good example of how the magnitude of a force can affect the distance an object travels and the path the object takes. In the first video, the boy shoots the basketball at a low angle with a certain force and misses because the angle was not high enough for the ball to reach the basket. In the second video, the boy shoots the ball at a higher angle with the same force as he did in the first shot. This time he makes the basket because his angle was high enough for the ball to reach the hoop. In this example, we see a boy hitting a ball with a stick. The first time he hits the ball, it does not travel a very far distance due to the fact that he hit it with a very small force. The second time he hit the ball, he hit it with a greater force and the ball traveled a greater distance. first video, the ball is dropped and it bounces back up because there is an equal and opposite force propelling it upwards. However, in the second video, when the ball is dropped, it doesn't bounce back up because there is not an equal and opposite force propelling it up. And to think, it all started with just a simple apple.